What do you do when you need to automate an inspection task where traditional machine vision is insufficient and machine learning cannot do the job on its own? You use experience, craftsmanship to put together a unique vision system that combines the best of both worlds. At JLI, we call it hybrid vision. Complex challenges call for well-thought-out solutions. At JLI, we call it hybrid vision as a term for vision solutions where we combine traditional 2D vision and sometimes 3D with machine learning and skilled craftsmanship. The most obvious use case for hybrid vision is inspection for aesthetic defects, like defects in the surface of, for example, a lacquered board like this. There can be over 25 different defect types in the surface, everything from pinholes, scratches, orange peel, dust in the lacquer, and so forth. And it will be very time-consuming to develop an algorithm capable of finding and classifying all the defect types because of the high variance in defect types, if not outright impossible. In this case, we can use machine learning. We can train a neural network on a large amount of good and bad images, and the network will then be able to assess with a certain probability whether there are surface defects and what type of defects are present. Even though you can buy standardized commercially available machine learning solutions, they often cannot be used when the complexity of the task is high. At the same time, it is often not a good idea to process an entire image with machine learning. It will simply take too long. And so traditional machine vision comes back into the picture again. By using traditional machine vision to pre-process the image and identify areas that could potentially contain defects, we can simply let our neural network process the relevant sections of the images and optimize the process. The neural network will then assign each section a value according to how likely it is that an image contains a defect, and some will be quite close to the threshold we have set. Again, we can bring traditional machine vision into play and post-process by having an algorithm look for specific errors that we know are particularly important. So we can narrow down the range of outcomes, and in this way, it becomes possible to use traditional vision to increase the accuracy of the inspection and avoid false rejects in borderline cases. Behind it all lies a third element, craftsmanship. Making an effective vision system for aesthetic applications requires deep expertise in basic vision skills such as lighting, camera technology. Without the right quality of images to be processed, even the best machine learning network will fall short, so this is crucial. But if you have the right foundation of craftsmanship, you can combine traditional machine vision and machine learning to create systems that can solve even very complex inspection tasks.